So in this video, we're going to do something called a direct conversion. So previously, we had binary to decimal to hexadecimal, right? We would put hexadecimal. And then if you want to go back, you would have to go to decimal back to binary, right? But for our video, we've already done this. So that was our previous video. But our focus is going to be binary to hexadecimal direct conversion. So this is our direct conversion. How do you do a direct conversion from binary to hexadecimal without going to decimal? Okay. So here's a little interesting trick. So we'll cover this in this video. This is actually really easy, and we're gonna do this right now. Okay. So let's take the number. I'm just gonna make up a bunch of numbers, but 1 1 0 1 0 1 1 1 binary. Okay. Now in a hexadecimal format, we always have to remember 0 through 9. Right? 10, 11, 12, 13, 14, 15. We write A, B, C, D, E, and F. Okay? And what we do is we just simply write the following, right? So how do we handle this? Well, it's very simple, okay? We do everything in sets of 4s. Okay, so this is 4, 4. So here is 0, 1, 2, 3, 0, 1, 2, 3, just like that. So this is our 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the 0, 2 to the first, 2 squared, 2 to the third. Okay? Now, obviously, if there's a 0, you don't even look at it, right? Just don't even look at that. So we have 8 plus 4 plus 1. Skip this because it's a 0, okay? We're going to skip that. 4 plus 2 plus 1. We end up with what? 13, 7. What's the number 13 in hexadecimal? It's D. So the number is D7 hexadecimal. Okay. So let's look at, well, the question is, how do we go back to, let's go back to decimal, right? How do we go back from D7 back to 1 1 0 1 1 0 1 1 1? Okay. So the conversion back, excuse me, is, I'm going to write it back out again real quick, is D is again the number 13. And we write out the number, obviously the number 7. What we do here in this situation is simply kind of do the same concept. It's slightly different. 8, 4, 2, 1. Here we have 8, 4, 2, 1. Okay? Now we could have done 8, 4, 2, 1 here. It would have been the same thing. 8, 4, 2, 1, but So what happens here? How do we come up with the number 13? Well, the number 13 is 8, 4, and 1. What's the number 7? 4, 2, and 1. So the number is 1, 1, 0, 1, 0, 1, 1, 1. So your complete answer is 1, 1, 0, 1, 0, 1, 1, 1. Binary. So let's do another example. Okay. Let's try this number here. Yeah, let's try this number here. What about if we had less than 4? We're not in the ideal situation, right? We're just simply not in the ideal situation. Let's do 1, 0, 1, 0, 1, 1, I'm sorry, 0, 1, like that. Eraser, 0, 1. Okay, binary. And we want to make this hexadecimal. Okay, well, again, what's the first thing we do when we operate with hexadecimal? we simply write the answer. We write the basic 10, 11, 12, 13, 14, 15. This is A, B, C, D, E, F. Okay? We just do that. Now, what you want to do in this situation is you have this kind of crazy number. You want to group it into a group of 4. So 4, and then you have 3. What do? Well, write out the 4 here, right? Here. And then here, it would be 0, 1, 0, 1. Here. Okay? So this is going to be what? 2 to the 0 power, 2 to the first power, 2 squared, 2 to the third. 2 to the 0 power, 2 to the first power, 2 squared, 2 to the third. Okay? So you would have, again, we go through this mechanism of here, that's 2 to the 0, which is 1. This is obviously 0. This is obviously 4. 4 plus 1. Here we have 1. We have a 0. And then we have a 4 here. So we have a 4 plus 1. This gives us 5. This gives us 5. So your answer is 55 base 16. Okay, it's not the best handwriting, but 55 base 16. Okay, how do I go back from 55 base 16? How do I go backwards? How do I know this is correct? Well, simply, we use the same algorithm to go back. Okay, 55 base 16, you have a 5, split up the 5. Okay, and then you write the following: 8, 4, 2, 1, 8, 4, 2, 1. Okay, what plus what gives me 5? 4 and 1 give me 5. What plus what give me 5? 4 and 1 give me 5. So your answer is 0, 1, 0, 1, 0, 1, 0, 1. So your answer now is 0, 1, 0, 1, 0, 1, 0, 1, base 2. Okay, that's just straightforward. Okay, now we'll do one more example. Okay, do something a little more fancy. What if you get a situation 1, 1, 0, 1, 0, right? Oh my gosh, what am I going to do? Okay, well, this is base 2, right? And what is this in hexadecimal? Well, what we want to do is type in 10, right into 11, 12, 13, 14, 15. A, B, C, D, E, F. Don't ever guess, just write it down. Okay? And you want to set it into a group of 4. So here comes here 1, 0, 1, 0. You take this and make into a group, another group, 0, 0, 0, 1. Okay? Same thing, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, but you have a separate zeros here. And so now what you want is something, you just keep doing the same thing over again. 2 to the 1, 2 squared, 2 0, 2 to the first, 2 squared, 2 to the third. 2 to the 0, 2 to the first, 2 squared, 2 to the third. Okay? So now it's what? What's at 1? Well, 4 is at 1, and then you have 2 to the third is 8. Okay? Obviously the zeros don't count. Okay? Here, what is under the 1? You have 2 to the first, which is 1. Zeros don't count. Okay? So, I'm sorry, that's not a 4. I apologize. I'm sorry, I apologize. So, 0 times 2 to the first, well, is going to be 2 to the first, which is 2. Okay? So you end up with a 10. But what's a 10? A 10 is A. Right? So your answer is 1, A. Base 16. Okay? How do I go back from 1A base 16? I follow the same procedure as I did previously. 1A 16. A 1. Okay? Our A gives us 10. A 1 is 1, right? So we write 8, 4, 2, 1, 8, 4, 2, 1. What gives us 1? Well, 1 is going to give us 1. What gives us 10? 8 and 2. So it's 1, 1, 0, 1, 0, 0, 0, 0, 1. So we end up with, we're not worried about that. 1, 1, 0, 1, 0. Base 2.